So example 1, find the quartiles of the following set of data. The first thing that we have to do is to arrange the data in order smallest to largest. So we've got, what have we got? We've got 2, 5, 6, 7, 10. And 12, 13, 14, 16, 22, 45, 65. We now have the data in order, and if you count the entries, there are 12 numbers. What we have to do is to find the middle entry. So 12 divided by 2 is 6, and that means we'll take the average of the 6th and the 7th piece of data. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So that's the middle entry there. That's what we call Q2, also known as the median. What's halfway between 12 and 13? It's 12.5. Let's just check that we have the middle entry. So if I count here, the bottom half, 1, 2, 3, 4, 5, 6, below, 1, 2, 3, 4, 5, 6 above. So the data is divided into 2 equal parts. We now find the median of the bottom half of the data. So I've got 6 pieces of data in the bottom half. Half of 6 is 3, so I take the average of the third and the fourth. 1, 2, 3 and 4. Here is Q1 here. And Q1, halfway between 6 and 7, is 6.5. 1, 2, 3, 4. Now this is interesting, this is a bit more complicated. This is Q3, the median of the upper half of the data. What's halfway between 16 and 22? Well, what we can do is add the two numbers together and divide by 2. So that gives us 38 over 2, which is 19. So we've now got the 3 quartiles. Here they are here. And one thing that we can do with the quartiles is work out the semi-interquartile range, which is a measure of the spread of the data. And the formula for that is Q3 minus Q1 over 2. So that's 19 minus 6.5 over 2. And that's 12.5 divided by 2, which is 6.25. You need to be able to do that as well. Is here. So here we have a second set of data. As you can see, the data is already ordered, so we don't need to worry about that. We want to work out the quartiles and the semi-interquartile range, and perhaps the mean, mode, median and range as well, just to be able to do everything. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pieces of data. Now 11 is an odd number. Unlike in the previous example where we had an even number of data, we've now got an odd number. So how do we find Q2, the median? 11 plus 1 is 12, divided by 2 is 6. So it's the 6th entry when the data is ordered. 1, 2, 3, 4, 5, 6. Here it is here. Now, what we have to do, remember Q2 is the median, the middle number of an ordered set of data. Let's just check. We should have the same number of data below, 1, 2, 3, 4, 5, as we have above, 1, 2, 3, 4, 5. So the number 9 is the median then. We want to work out the value of Q1. Well, that's the median of the bottom half of the data. So we have 5, numbers below the 9. 5 is an odd number. 5 plus 1 is 6 divided by 2 is 3. So this number here, 1, 2, 3, this number then, 5, is the value of Q1. And we've got 5 pieces of data in the upper half, so it's going to be 1, 2, 3, here it is here, 18. So there were no problems calculating the three quartiles. We should probably state those quite clearly though. That's 5, median is 9, and Q3 then is 18. So what else can we do? We can work out the semi-interquartile range. The formula is Q3 minus Q1 over 2. So it's 18 minus 5 over 2. And that's 13 over 2, which is 6.5. What else can we do? We could work out the range. So that's largest. Take away the smallest. And that will be what? 27 take away 1, which is 26. We don't have a mode, because we don't have any number occurring more than once, so we don't have a mode. That's a bit unusual, but there we are. We've done the median is Q2, that's 9. The median is 9. If we wanted to work out the mean, how would we do that? The mean is, well, we'd have to add them all up, so 1 plus 2 plus 19 plus 27. We know that there are 11 numbers. It's 121 over 11, which is 11.